Welcome back, everyone. This is Dr. Gallenstein, and today we are in the third lecture in a series on equilibrium and efficiency. In this series of lectures in general, what we're talking about is how individual rational agents interact with each other in a market setting and the consequences of the behavior of rational agents at the social level. And basically what we've demonstrated is that in a free economy, an economy characterized by free exchanges between rational agents, that the economy will achieve an efficient equilibrium. We've defined efficiency according to the principle of Pareto optimality. An outcome is efficient if no one can be made better off without making someone else worse off. We showed in the first lecture, we discussed these concepts conceptually in the first lecture, and then the second we illustrated them using the Edgeworth Box. Today I'm going to do two things. First, I want to introduce the concept of prices and the role that prices play in this free market exchange economy. And then next, I want to talk about some of the implications of these principles that we've laid out. Specifically, I'll talk about the welfare theorems of economics and how these might influence the design of policy. Okay, so let's begin with that. I want to begin by talking about prices. What's the role of prices in this free economy? Well, first, I want to begin by expressing it mathematically and then conceptually. Okay. So, expressing it mathematically, let's go back to the individual's utility maximization problem using cereal and bagels, that an agent will choose how much cereal and bagels to consume in order to maximize the utility, subject to their budget constraint. So the price of cereal plus the price of bagels. Okay, so now in this context, we can see that prices are going to play an important role in the maximization decisions of the agent. So when the agent is choosing how much cereal to buy and how many bagels to buy, the prices of those goods are going to influence that decision-making process. Okay. Now, when they do the maximization, as you remember, we will find the demand functions for cereal and bagels, C star and B star, the optimal consumption of both of the two goods. Okay, and we can illustrate that maximization process graphically by using the same graph that we've used many times now. That is, a graph with indifference curves. We always know that agents want more of both goods. More is always better, according to a rational agent. All right, so they always want bundles on higher indifference curves, but they are constrained by their budget, okay? And we illustrated that graphically by drawing this budget constraint, or this budget line L. And so they will choose the bundle, the combination of cereal and bagels on the indifference curve furthest away from the origin that simultaneously lies on the budget constraint. And so the budget constraint is basically this. It's basically all the possible bundles that the agent can afford to buy, and so they will choose a bundle that lies on what's called the budget line. The budget line is kind of like the threshold, the maximum amount. All the bundles on the budget line are the largest bundles that the agent can afford to buy given their income. And so they will choose the bundle on the indifference curve furthest from the origin that is still feasible, that is, still satisfies the budget constraint, which means it's where it lies on the budget line. All right, so here is the optimal point, oh boy. All right, so this point here. All right, and at this point, this is the bundle C star and B star. All right, so now given this illustration, I want to walk us through what are the role of prices, or what's the relationship between these consumer decisions and prices. Okay, so to do that, let me illustrate a couple things. First, I want to derive what is this budget line? What is this? What is the function for this budget line? And specifically, I'd like to know the slope. Why do I want to know the slope? Well, I know that the slope of the indifference curve is the marginal rate of substitution. The slope of the indifference curve is the marginal rate of substitution, which is the ratio of the marginal utility of bagels to marginal utility of cereal. All right, but now I want to know the slope of the budget line, and I want to know that because when I look at this point, when I look at this equilibrium point here, optimal point here, when I look there, I can see that the marginal rate of substitution is equal to the slope of the budget line. All right, so let's figure out what the slope of the budget line is, and that might give us some information about the relationship between the agent's preferences and prices. Okay. So there's our justification. Let's go ahead and do it. So if we want to derive our budget line, let's start with the budget constraint. Okay, here's our budget constraint. Then we need to recognize that this budget line is a line in the space of cereal and bagels. That means this budget line can be expressed as a function C of B. Basically, we can think of the budget line as this. This budget line tells us how many bowls of cereal the agent can afford to buy given how many bagels they've already bought. So basically, if they've bought this many bagels, this is the number of bowls of cereal that they can buy. If they've purchased this many bagels, this is the number of bowls of cereal that they can buy. All right, so that's basically what this line does. If that's the case, then all we need to do is solve this equation for C. So let's solve this for C. All right, we'll bring this to the other side. Nice. PBB equals PCC. And I hope you, just for aesthetic reasons, make it cleaner. I'm just going to flip the sides here. I hope you are okay with me doing this. Okay. Now I'm going to divide both sides by PC. And so I get C alone. C as a function of B is now this. I over PC minus PB over PC times B. So now I have a function, the number of bowls of cereal that the agent will buy given how many bagels they have. Now if I want to know the slope, I'll take the derivative of C with respect to B. Derivative of this first term is 0. Derivative of this term, all right, it's PB over PC. All right. So now we can come back and we can articulate the relationship between preferences and prices. The marginal rate of substitution is equal to the slope of L. All right, well, let's formalize that. The ratio of the marginal utilities will be equal to the ratio of prices. See here the negatives will cancel out, so let's just get rid of the negatives and rewrite it. So the ratio of the marginal utility of bagels to the marginal utility of coffee will be equal to the ratio of the price of bagels to the price of coffee. Okay, so there's a necessary relationship between prices and agents' preferences. There's a necessary relationship between the prices and the agent's preferences, and we derive that. We can see that from the utility maximization problem. Now, this will be very important when we think about this at the economy level, at the economic level. Now, when we look just at an individual's decision-making process, we treat the prices as fixed. The prices are just given. And if the prices are just given, then the agent will choose a bundle such that the ratio of their marginal utility for these goods will be equal to the ratio of the prices. Okay. But in an economy, especially if we go back to this Edgeworth box and we have an exchange economy, in an economy prices can change, prices can fluctuate. When we see this, we gain some insights. Okay, so in an economy, what we will see is that prices are partially determined by the preferences of agents in the market. Okay, so with that said, let's go back to the Edgeworth box from the last lecture, and we'll illustrate the role that prices play in allowing a market to achieve an efficient equilibrium. Okay, remember this. I'm going to put this up here in the corner. All right, marginal rate of substitution equals the ratio of the marginal utilities equals the ratio of prices. Okay, we just want to remember this. All right, we've derived it here. We see it here. Let's go to our economy. Let's go to our Edgeworth box pure exchange two-person economy, and we'll illustrate the role that prices play. All right, and it'll have some important implications for us. All right, now first, remembering our Edgeworth box, I'm going to draw the Edgeworth box here, and I'm going to leave us enough space to the side so that we can do some other math. All right, so here's our Edgeworth box. All right, bagels, cereal, and let's assume that we've reached, let's use the same colors last time. Let's assume we've achieved some equilibrium. Now we're going to call it E, okay, and all right. Okay. So we achieve some equilibrium E. And at this point, right, at point E, the marginal rate of substitution for person 1 equals the marginal rate of substitution for person 2. All right, so we know that. Actually, I'm going to write that up here. Get it out of the way. Marginal rate of substitution for person 1 equals the marginal rate of substitution for person 2. Okay. Now, let's think about what role do prices play in this economy? So we've already used that color. Let's use one. What role do prices play? Well, first, when we're in this Edgeworth box scenario, we need to understand, well, what does it even mean to have a price? So let's just illustrate that a little bit. Let's imagine we had a scenario where person 1 starts off with 1 bowl of cereal, 9 bagels. Person 2 starts off with 9 bowls of cereal, 1 bagel. In this case, we might say that the price of cereal is equal to 1 bagel. And the price of bagels is 1 bowl of cereal. So in this Edgeworth box, this would be the scenario. All right. So because it's just trading, it's actually not in terms of money per se, but in terms of units. We can think about this. We can think about this a couple different ways, but this might be illustrative. So remember, they made an exchange. The first exchange, they just traded 1 for 1. So I traded 1 for 1. They've basically said that the price of cereal is 1 bagel, etc. Okay, that just makes this a little bit more tangible. Okay. So in this economy, we can also imagine this. Person 1 is trying to maximize their utility subject to the constraint of what they're able to, basically what they're able to, quote, purchase, in this case, trade for, with person 2. All right, this is person 1, person 2. Okay. And so now, taking into consideration the role that prices play, remember before that the marginal rate of substitution equals the ratio of prices. Well, now in the Edgeworth Box scenario, we know that at an efficient equilibrium, the marginal rate of substitution for person 1 equals the marginal rate of substitution for person 2. What does this imply about the role of prices? This is what it implies. The marginal rate of substitution for person 1 equals the ratio of prices. At the equilibrium, this also equals the marginal rate of substitution for person 2. What does this mean? This means that prices are set. Actually, I don't like the word set. That makes it sound like someone is setting them. Let's change it. Prices reach the point at which the marginal rate of substitution for person 1 equals the marginal rate of substitution for person 2. So here's the insight. Prices are a result of the preferences, and at equilibrium, prices are such that, so the prices are established such that the equilibrium is possible. That is, the marginal rate of substitution, at equilibrium, the prices are such that the marginal rate of substitution between the two agents are able to equal each other, which means they will be efficient. What's that mean? It means that the prices are the mechanism. The prices are, in a sense, the mechanism for how the economy is able to reach this equilibrium, because prices will adjust so that the marginal rate of substitution for person 1 will equal the marginal rate of substitution for person 2. That's in our kind of stylized two-person economy. But the general principle can be expanded beyond that. That is, that prices adjust. If the economy is free, prices will adjust such that an efficient equilibrium is possible. So what are the implications for this? The implications are this. This efficient equilibrium, E, is characterized by the way that goods are allocated. So that is person 1's consumption of cereal, person 1's consumption of bagels, person 2's consumption of cereal, person 2's consumption of bagels, as well as the price of cereal and the price of bagels. And the prices are set such that the market is able to achieve an efficient equilibrium. And they're not set by someone else. They're not set by someone imposing prices on the economy. They're not set by the government or anything like that. The prices emerge from the trading, from the voluntary exchanges. And then the prices settle on a point that allows the economy to achieve an efficient equilibrium. So basically this, in a free economy with rational agents, the prices will adjust until they reach the point, until they reach a point such that all possible beneficial trades can be realized. And the prices at which all possible beneficial trades can be realized, those prices will be the prices at the efficient market equilibrium. So therefore, prices serve an essential role in free markets, because the prices emerging from the preferences of consumers will communicate the market value for the goods, and they're a mechanism by which the market is able to achieve efficiency. This implies that if prices are distorted, the market will not be able to achieve an efficient equilibrium. Okay, so that's the role that prices play. I think that might even be more clear in the next lecture when we actually solve for an equilibrium mathematically. So let's settle on this for now, and we'll come back to it and discuss it a little bit more when we get to the next lecture. For the remainder of this lecture, what I would like to do is I'd like to talk about some of the implications of efficiency and equilibrium. What are some of the implications of what we've been talking about? Basically, what we've said so far is that an economy, a free market filled with voluntary exchanges, will reach an efficient equilibrium. Well, what are some of the implications of that? Well, in order to do this, I want to talk about two things. I want to talk about what's called the welfare theorems of economics. Okay, I want to talk about what these are, and then I want to use them as a basis for a discussion of policy, which we'll do mostly in class, but I will maybe just illustrate something here. So first, I just want to kind of draw our Edgeworth box again and assume that we have initial endowment W. Okay. All right. There are two welfare theorems, the first and the second welfare theorem. All right, these welfare theorems basically summarize the conclusions of the discussion that we've had so far. Okay, the first welfare theorem basically says this, that a free market, so basically there's no coercion. Actually, I don't know how to spell coercion. So there's no coercion. Okay, so in a free market, no coercion, that means voluntary trades. A free market will achieve an efficient equilibrium. It will achieve an efficient equilibrium. So efficient meaning Pareto optimal. Efficient equilibrium without any intervention. Without any intervention, the government doesn't need to do anything. The market, on its own, left to its own devices, will achieve an efficient equilibrium. In this equilibrium, no one can be made better off without making anyone else worse off. Moreover, the efficient equilibrium, the market will clear. By that we mean that all goods are consumed. Nothing goes to waste. All right, all the goods are consumed, nothing goes to waste. So the first welfare theorem is basically kind of like a summary of what we've been saying this whole time. That if the market is free, voluntary trades are allowed, then the market will reach an efficient equilibrium. Markets will clear without any intervention, without any planning. Now that's basically a summary of what we've said so far. That has some significant implications, especially if we think about the past, when, especially the 20th century, that saw massive debates between the economic principles of capitalism and communism, where capitalism basically says, let's let the market allocate resources, and communism basically said that the economy would be it would be planned, that the government would plan the economy. It would allocate resources. The first welfare theorem says that a market left on its own without intervention will achieve an efficient equilibrium. So the free market does a better job of allocating resources than any type of planning. Okay, so that's the first welfare theorem. All right. The first welfare theorem basically establishes that we should just let the market trade. It'll achieve its own equilibrium that will be efficient. Okay, my equilibrium point here doesn't quite fall at the intersection. So let's do this. Okay. The first welfare theorem basically says we need to let the economy be free. If we let the economy be free, then we will achieve efficient allocation of resources because we will achieve the Pareto optimal outcome. So just looking at the Edgeworth box, it's basically saying that left to its own, we will achieve a efficient equilibrium, like we showed last time. All right. The second welfare theorem is motivated by the issue of equity. It's motivated by the issue of equity, or at least motivated by issues, maybe perhaps fairness. The second welfare theorem is motivated by the idea that, perhaps the free market is efficient, but one might be concerned that the free market isn't fair. And so the free market might be efficient, but maybe the free market isn't fair. And in fact, maybe, so this is kind of the motivating idea, maybe there's a necessary conflict between efficiency and equity. Maybe you can't be fair. Maybe there can't be equity or fairness in the equilibrium without sacrificing efficiency. Well, the second welfare theorem kind of settles this issue. Basically, the second welfare theorem says this: any equilibrium is the result of free trades or voluntary exchanges from some initial endowment. So what this implies is that efficiency and fairness can go together. Efficiency and fairness can go together. They're not in conflict. There's no essential trade-off between the two of them. Furthermore, this implies that if we want a more equitable outcome, what we need is to adjust the initial endowments. So to achieve an equitable equilibrium, adjust the initial endowments. So let's do this. Okay, so what I have here is basically my attempt to illustrate the first welfare theorem. Let me erase this, and then I'll try to illustrate using this the second welfare theorem. Okay, so let's assume that let's assume that we have an initial endowment. We have an initial endowment here. This is our initial endowment, W. Now you'll notice that in this initial endowment, person 2 starts off with very little. Person 1 starts off with a lot. Now, they're still able to enter into some voluntary trades, and maybe they'll trade to this point. Okay. And I'm going to call this E for equilibrium. All right, so they trade from the initial endowment to the equilibrium. At this point, person 2's indifference curves are going to be tangent to person 1's. All right, that's supposed to be tangent. So person 2's indifference curves will be tangent to person 1's. Okay. Now, this equilibrium E will be efficient. And I might put E1. So E1 is efficient. And it's efficient because of the first welfare theorem. It's efficient because of the first welfare theorem. It's efficient because it's the result of free and voluntary exchanges. They have reached an equilibrium point. All voluntary trades have completed. The market will clear. It's Pareto optimal. You can't make someone better off without making anyone else worse off. All right, E1 is efficient, and it is in equilibrium. Okay, but just by looking at this, we can tell. That this is not a very equitable distribution of the goods in the economy. This is not a very equitable distribution of the goods. Person 1 has way more than person 2. Maybe we think that some other equilibrium, some other point, let's say that this point here, maybe we think that E2 is more desirable. E2 is more equitable. So maybe we say we would rather have E2 than E1. Okay, but now I think we firmly established that that E2 is not feasible in this economy. So if we start with initial endowment W, E2 is not a feasible equilibrium because E2 would make person 1 worse off. It would make person 2 much better off, but it would make person 2 worse off. So E2 is not efficient when we start with initial endowment W. So if we start with initial endowment W, E2 will not be feasible. It will not be efficient. So if we only have voluntary trades, it will not be feasible. So E2 is not feasible with voluntary trades. E2 is not feasible with voluntary trades. The market will not achieve it with voluntary trades. Why? Because it's inefficient. Because it would make person 1 worse off. And as long as trades are voluntary, person 1 would never enter into an exchange where they would be made worse off. Because they're rational. They maximize their utility. Okay, so then, but let's say that we wanted E2 for some reason. Let's say that we want it. We want it for some reason. I mean, maybe it's quite obvious. We want the equilibrium to be more equitable. Well, at this point, if the initial endowment is W, maybe the government could intervene in the economy and it could adjust prices to try to or maybe regulate or do something to try to manipulate the market in order to get agents to trade from W to E2. But that would be, by necessity, inefficient, and therefore not feasible through voluntary trades. All right, so there's our problem. What does the second welfare theorem say? All right, just a reminder, first welfare theorem says that the free market will trade to an equilibrium that is efficient. The second welfare theorem says that E2 can be an efficient equilibrium, but only if the initial endowment is changed. Basically, these two agents will freely trade and arrive at E2 if the initial endowment is different. E2 is not efficient if the initial endowment is this dark green W. But if the initial endowment were this instead, if the initial endowment were this light green W, then E2 would be efficient. It would trade from this light green W to point E2. And so if the initial endowment is this light green W, then E2 is both equitable and efficient. It's both equitable and efficient. That's the second welfare theorem. So the implication of the second welfare theorem is that if we want to achieve an efficient equilibrium that's also equitable, what we don't want to do is intervene in the economy, change the prices, regulate it, or coerce behavior in order to get people to trade from initial endowment dark green W. What we want is to change the initial endowments, because if the initial endowments are set correctly, then even the equitable equilibrium is efficient. So there's no essential trade-off between equity and efficiency. An efficient equilibrium, an equitable equilibrium, can be efficient if the initial endowment is in the right spot. Okay, so how do the first and second welfare theorems influence our thinking about policy? So let me summarize a couple of points. There may be a couple of principles, and then we'll talk more about this in class. All right, I'll leave it in purple. Principle 1. Free markets achieve more efficient outcomes than planned economies. So the general implication would be certainly capitalism would achieve more efficient outcomes than communism. Those would be kind of the extreme examples, but more generally, that markets perform better when there are not interventions by, let's say, government agencies or things like that would kind of command and control, mandating how much producers should produce, or how much consumers should consume, or the prices at which goods can be sold, etc. That free markets achieve more efficient outcomes than planned economies. All right, that's the first implication, the general implication of the first theorem. The second one is that, and this is kind of tied to the first, distortions that alter prices or constrain voluntary trades result in inefficiencies. and inefficiencies. Bad policies, basically. All right. 3. If we want to achieve more equitable efficient outcomes, we need to think about initial endowments. So equitable distributions of initial endowments how do we put, let's change how I'm putting this. So if we want to achieve equity and efficiency, so let's say we have some policy target, like we want to improve nutritional outcomes for families, or we want to make the income distribution more equitable, or we want to raise living standards. So if we want to achieve a more equitable equilibrium, then the way to do that would be pursue more equitable initial endowments. So if we have some policy objective, so putting this together, if we have some policy objective, it would be better to help people or to help the economy have a more equitable distribution of initial endowments than it would to alter the nature of the exchange process, like changing prices or constraining voluntary trades. We talk about this in class, and so I won't go into length here, but we can think of a couple of different examples, a couple of different kind of hot button topics where this might apply. And now I will caution what I say here in terms of policy, because these welfare theorems are very important, and they certainly, I would say, really kind of form the basis of an economist's approach to policy design, but they're not the end-all be-all. The story is not complete. So I put a grade of caution, but just in terms of applying what this would look like, imagine we had a situation where we wanted to help households achieve better nutritional outcomes. There's a couple of different options, policy options that we might take. One option is maybe we tell grocery stores the price that they can charge for vegetables. And we say that they have to lower their price of vegetables by 50%. If we did that, demand for vegetables would go up, more people would buy them for sure, but it would create a deep distortion in the market. Altering the prices would create a deep distortion in the market where we're eliminating the incentive for producers to produce those vegetables. And so what we would end up with is a shortage of vegetables. It would create an inefficiency in the market. We could also constrain voluntary trades, where we say that only certain kinds of people can buy vegetables, or we say that certain people are not allowed to buy things other than vegetables. Again, we're constraining voluntary trades. Those approaches would be a bad way of approaching the policy objective of trying to improve nutrition for households. Something that might be a little bit better is what we do, the Supplemental Nutrition Assistance Program, where we provide households with income that can be spent on food. It doesn't alter the prices. It doesn't manipulate the market. Markets are still allowed to be free, but in a way we've redistributed the initial endowments. The initial endowment of income in this example. And then agents can make free and voluntary exchanges in that context. Now, but we might argue that that policy isn't perfect in the sense that we are constraining the voluntary trades such that the agents can only spend that money on food. We might look at that scenario and say that, well, we would prefer an unconditional transfer of income. Instead of money for food, it's money for anything. And then agents can make voluntary trades, make the full range of voluntary trades. Maybe they don't want to spend all of that money on food. Maybe they would spend some of it on other things. Okay, so that would be an example. We might take another example. Let's say the minimum wage debate. Just using the welfare theorems of economics, we would conclude that minimum wages are not an effective policy. Why would we conclude that? Well, let me draw another illustration to kind of illustrate why we would conclude against minimum wage. Now, again, these arguments don't settle these debates. Okay, so we're considering this perspective from the perspective of the welfare theorems, but the story is not finished. Okay, but imagine that I have, again, so we have a business, okay, and I have a business, and I have a potential employee. And let's say this employee is a high school student. So they're a high school student. Okay, and there's a business. When the government sets a minimum wage, what happens? The government is constraining voluntary choices. The government is telling the business that they cannot pay anyone. Let's say the big one recently has been they cannot pay anyone less than $15 an hour for their labor. So they've ruled out anything less than $15. They're also telling the student that the student is not allowed to accept less than $15 for their labor. So it's constraining their set. Now let's consider an average high school student. The average high school student has no job experience. They are only available to work part-time. To them, a job making $8 an hour for a couple hours after school might be very well worth it. In fact, because they have no job experience, they might not have as much to offer a business. So they might be very happy to work for $8. Their utility might increase if they were able to get a job and make $8 an hour. But the minimum wage has constrained them. The minimum wage says that this person is not allowed to work for that. This person is not allowed to work for $8 an hour. Okay, well, they're only allowed to work for 15. That might sound nice. But let's look also at the other side of the economy. This business is not allowed to hire labor for less than $15 an hour. Now, maybe they have a job. Maybe this is a restaurant and they're hiring someone to be a dishwasher. Working as a dishwasher does not add $15 an hour to a value to the business. And so they're not willing to hire a dishwasher at $15 an hour. And so they actually don't employ the student. They don't employ the student because they can't afford to pay $15 an hour for a service that doesn't provide a tremendous amount of value per hour. And so in this case, the exchange doesn't happen. Now, the exchange would have happened without the constraint. The business would have been willing to hire the student at $8 an hour, and the student would have been willing to be hired at $8 an hour. In that case, there would have been a Pareto improving trade. The student would have provided their labor at an agreeable amount, $8 an hour. The business would have provided wages for an agreeable amount of $8 an hour. That trade would have been a Pareto improvement. It would have made both agents better off. But because the minimum wage is set at 15, now these possible trades don't exist. When these possible trades don't exist, the businesses are left without the employment that they need, and the high school student is left without, the business is left without the labor that it needs, and the high school student is left without a job because the voluntary trades have been constrained. By manipulating the price, there are voluntary exchanges in the market that are not allowed to occur, which means that we're not able to achieve all the possible Pareto improving allocations, and the market will not achieve a Pareto efficient equilibrium. All right, so obviously that doesn't settle the minimum wage debate, but it is an illustration of how these welfare theorems might apply to that concern. All right, in the next lecture, I will take all of this into some mathematics, and we will actually solve a math problem for an efficient equilibrium. And I will see you again next time.